Let's take a look at your 10.6a notes, counting principles, permutations, and combinations. The fundamental counting principle states that the number of ways in which a series of successful things can occur is found by multiplying the number of ways in which each thing can occur. So example 1a, how many outfits can you create with 4 shirts and 6 pairs of pants? That is with replacement. You're just multiplying your choices together. 4 times 6, you've got 24 outfits. Now when we come down and we look at permutations. Now permutation is an ordered arrangement of items that occurs when you've got no item is used more than once, there's no replication. The order of arrangement makes a difference. Here's your handy dandy formula. I'm sure that you all realize you have a key in your calculator to calculate this, which is fine and dandy. Please use that to check your work. But again, I want to see your actual work with your factorials on your homework and on your test. So I want to go ahead. This example 2. Okay, we use the formula here. We've got you and 19 of your friends, that's 20 people, have decided to form an internet marketing consulting firm. We need 3 officers, a CEO, an operating manager, and a treasurer. Okay, so that is 3 choices. We need a CEO, operating manager, and a treasurer. Now, fundamental counting principle, again, states number of ways in which a series of successive things can occur by multiplying the number of ways in which each thing can occur. So my first choice here, I need a CEO. Well, right now I have 20 people to choose from. So this is now without replacement. Now I've got that one guy is sitting here, which means I only have 19 people left to choose from for my second position as an operating manager. After that position is filled, well, now there's only 18 people to choose from. If you multiply 20 times 19 times 18, guess what? You're going to get 6,840 ways. Let's tackle some of our you tries. Number 3, this one is dealing with permutations. And how many ways can 6 books be lined up on a shelf assuming order matters? This right here tells us it is a permutation. So permutation, we have, let's see, our total, our N is 6. And then our R is going to be 6. My formula is N factorial, so that is 6 factorial, all over N minus R factorial, which is 0 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 0 factorial is 1. If we multiply this out, we are going to come up with 720 different ways. And now let's look at number 5. This deals with combinations. We just worked with combinations. This is your binomial coefficient. The order in which your formula is presented to you is just a little bit different. It still means the same thing. You can still, of course, use the calculator to calculate these to check your answers. I still want to see your work. So here we go, number 5. How many different 4-card hands can be dealt from a deck that has 16 different cards? Notice here, order doesn't matter. Our N value is 16. It's a combination. So out of 16, I'm going to choose 4. How many different ways can I do that? Your formula states N factorial all over N minus R factorial. 16 minus 4 is 12 factorial times R factorial. Let's start breaking this down. We have 16 times 15 times 14 times 13 times 12, and I'm going to leave it because I've got a 12 factorial in the denominator. Let's leave that factorial in the numerator. Times 12 factorial. These will reduce out. 4 factorial is 4 times 3 times 2 times 1. Okay, so 12 factorial over 12 factorial is 1. 16 is divisible by 4. Let's reduce that. 15 is divisible by 3. Let's reduce that. 14 is divisible by 2. Let's clear that out. And I am now left with 4 times 5 times 7 times 13 all over 1. That is going to give me an answer of 1,820 hands.